Alright, so this lesson is about geometric proof or geometric proofs. Yesterday we did algebraic proofs, which you remember was solving an algebra equation and writing out the reasons on the side. Okay, that probably didn't seem that difficult. That wasn't that bad. Okay, geometric proofs. This is the part your parents warned you about. Okay, if you have a parent that remembers when they took high school geometry and you ask them about the proofs, you'll probably see them get goosebumps or see their skin crawl. They'll say, "Oh my God, the proofs, ugh, it was miserable." Okay, I promise you that it's not that bad, and all you have to do is take it one step at a time. Don't get behind, and listen to the things I tell you. Okay, if I give you a piece of advice, you need to remember it. Okay, there's only a couple of things that can happen with a proof. Okay, we're going to be given some kind of information just like we were given those equations, and we're going to work our way towards a final solution or a final conjecture or something at the end, and it's going to follow a logical process. It's going to be like baking a cake. Okay, a lot of people say, "Well, I can't bake." Well, that's ridiculous. There's printed instructions that you follow, right? It says mix the eggs. You mix the eggs. It says put in a glass pan. You put it in a glass pan. It says put it in the oven. You put it in the oven. Now, I probably left out a few steps there when I was describing how to make that cake. And if you leave out steps in your proof, that's when the problems are going to come up. Okay, I'm going to show you how to do one tonight. We're going to practice them a lot, and we're going to do them for the rest of the year. So we're going to take it nice and slow. A couple of things that you need when you're doing a proof is you need theorems. Okay, theorems is a fancy way of saying a fact or something that you know. A theorem is any statement you can prove. Okay, just something you can prove. And most of the theorems we use in here, we're going to prove them before we use them. And the other thing that we're going to use a lot of is a postulate. And you know what a postulate is because you already have a flashcard that says postulate on one side, and on the other side says accepted without proof. So theorems and postulates are both facts or statements. Okay, theorems we prove, postulums we just accept them, we don't prove them. So I'm going to tell you a new theorem that you've never heard before. So it should be new and exciting, right? It's called the linear pair theorem. Hopefully you recognize that because it's on your outline that you've had for well over a week now. It's something that you should be making a flashcard of. And it's something that you're going to be responsible for knowing. You have to memorize it. You have to know exactly what it means and exactly when to use it. The linear pair theorem says if two angles form a linear pair, so if two angles form a linear pair, then they are supplementary. Okay, so two angles form a linear pair, then they are supplementary. So let's just look at what that looks like. Hopefully you remember that this is what a linear pair looks like, and it would have maybe an angle 1 and an angle 2. Well, they're on a line together, aren't they? Angle 1 and angle 2. So hopefully you kind of don't need much convincing that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Hopefully that's pretty okay with you. You don't have too many problems accepting that. Now, the reason that you accept it is because you know what supplementary means, right? And you can see the picture here. You can see it. It's clear. A proof is like a way of justifying this to somebody that has no idea what any of this means. Okay? Now you know what angles are, you know what a linear pair is, you know what supplementary means, and you look at this picture and you might just get it, right? You might just say, I get it, that's cool. Well, a proof, which is what we're about to do, is a way to explain exactly what's happening. So we're going to do a proof. So this is your first real proof that you're ever going to do in your life. So it's a special moment, right? I want to pause it. Go get yourself a soda or something, right? It's going to be exciting. All right, so we're going to do a proof. I'm going to draw a couple of angles here. We're going to have an A, B, C, and a D. All right, so we have angle ABD and angle DBC. I'm going to advise you to pause frequently. Make sure that you keep up with this. Now, most of the time when you have a proof, you're also going to get given information. Something is going to be given to you. You're not just going to start with a blank paper and they're going to say, prove that the sky is blue, or prove some other ridiculous statement. They're going to give you something very basic and very straightforward. And what I'm going to give you for this proof is that angle ABD and angle DBC form a linear pair. Okay, so you don't need to worry about whether this is a linear pair or not. It is. If it's given to you, you can accept it, and it's part of your things you can use in your proof. Now, when you write a proof, we write what's called two-column proofs. On one column, we have statements. Statements are things that we want to say, or steps in our process, but we can't just say them. For every statement we make, we have to have a reason. And our reasons are our theorems, our postulates, and sometimes our definitions. Okay, so we're going to try to go through here, and what we're going to prove, we're going to prove the linear pair theorem. So this theorem up here that I just gave you, that I just said, you guys probably get it, right? Like this one plus this one adds up to 180. Great. Somebody may not get it. What a proof does is it gives them all the reasons that it's true. So almost always with your proofs, you're going to start out with your given information. So my given information says that angle ABD and angle DBC form a linear pair. Now you have lines on your paper, so you might be able to fit that all on one line instead of like I did. But when you do a proof, you want to number each line. So this is line 1, statement 1, and I'm going to have a reason 1. And the reason I know that ABD and DBC form a linear pair is that that information was given to me. So now I'm going to go to my next line. The next thing I'm going to say, now, it's good to think your way through a proof before you just start writing. So my linear pair theorem says that this plus this is 180. So the 180 part is because this is a line right here. AC is a line. So I really need to show that this is a line, and I need to show that this adds up to 180, and then I need to show that 180 means supplementary, because somebody may not know what supplementary was. So I kind of keep all that in mind as I'm working here. So on line 2, I'm going to say that ray BA and ray BC form a line. Okay, so how did I know that? So just because I know what a line is? So ray BA and ray BC form a line. Well, the definition of a linear pair says that a linear pair is formed by adjacent angles whose non-common sides form opposite rays. Right? And these opposite rays form a line. I can see it right there. So the reason that I know all this valuable information is because of the definition of a linear pair. So I'm going to keep moving now. What else do I know here? I know something. Remember, I know that I get a line here, so that's good. Now I need to say that that line is also 180 degrees, right? Because that's part of my supplementary. So I'm going to say that the measurement of angle ABC equals 180 degrees. Well, why can I say that? Well, what kind of angle is angle ABC? So that's the definition of a straight angle. You know straight angles, right? You know definitions. Just have to pull it all together here on this big long proof we're doing. Alright, so we're on to step number 4. So I've said that this is a line. I've said that this line is 180 degrees. But what I haven't said is that these two angles, ABD and DBC, have anything to do with this line. So I'm going to put that right here. I'm going to say that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. That probably got pretty small if you're watching it on your phone, but I set it out loud, so hopefully you can get it down. So how do I know that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC? How do I know that? It's something you learned. You should have a flashcard for it. It's called the angle. Now you see why we made all the flashcards. Angle addition postulate. Okay, I wasn't kidding you when I said you got to know them all. There's not going to be any kind of cheat sheets or formula cards on any of this. You really have to know them. Alright, so let's see. I've said that that's a line, so that's good. And because it's a line, it's 180 degrees. So I got that covered. Now I've even said that this one plus this one equals the line that I'm trying to figure out. Okay, so it's looking pretty good, right? Maybe why don't I just say that this one plus this one is 180 degrees. So I'm going to say the measure of angle ABD plus the measure of angle DBC equals 180 degrees. Now that line looks exactly like the line above it, right? Except for one detail. What's the one thing that I did different? Okay, I substituted the measure of angle ABC with 180. And that's one that you just wrote down yesterday. That's the substitution property of equality, right? So everything goes together, guys. This is geometry right here. Everything we did before was just kind of, it was kind of fun, kind of neat, but this is what geometry is. So I'm working it all through for you, so don't get too rattled if you have no idea what's going on. The important thing is that you stay with it and you try to get better each time, okay? So we're on to our last step. Okay, you don't know it's the last step, right? Because you've never done one of these in your life, but I know it's the last step. I'm going to write that angle ABD and angle DBC are supplementary. Now, why is that my last step? That's kind of an arbitrary point for me to just decide, say, okay, well, Texans game's about to start back up, so that's the last step. Okay, that's the last step because if we go back up to our linear pair theorem, it says if two angles form a linear pair, then they are supplementary. Well, I started here with a linear pair, right? Started with a linear pair. My goal was to show that they're supplementary. Now I've done that. And the final reason here, how do I know that they're supplementary? Right here I know that they add up to 180. So how do I know that means they're supplementary? And it's because of my handy dandy flashcard that tells me the definition of supplementary. Okay, so that is your very first geometry proof, and any of you guys that are going to go on in math, when you get to college, you're going to do a lot more of these. So if you're a sentimental kind of person, you might want to take that and save it away somewhere. It's the first proof you've ever done. Tomorrow in class, we're going to do congruent supplements theorem. So we're going to do that in class tomorrow. It's the next theorem in your textbook. If you want to look ahead at it, go ahead. But if not, we're going to do it in class tomorrow. See you later.